Hello grade 12s, welcome to my channel. Let us revise for mathematics. So this is the paper from KZN Term 1 2026. Unfortunately guys, we could not have our class because of some power issues. It's not so long that it came back. So I hope that you guys are doing great. We will carry on hopefully tomorrow. Right folks. Now, always we check out our instructions, and of course, if we just jump for the jugular for now, that would be better. And in fact, we just need 2 decimal places or no decimal place at all. Right. Let's make it a bit bigger. Right, let's get to question 1. So question 1 tells us that 26, 45, and 70 are the third, fourth, and fifth terms of a quadratic number pattern. Now we need to find the first term of the quadratic number pattern. Not a problem. So we've got 1.1. So we will have the first term, second term, and then we've got our third term 26, fourth term which is 45, and our fifth term 70, and the pattern continues. And we know guys, we always have the sequence of first differences, so we're going to use that to our advantage. Okay, so let's see, this is 70 minus 45. This gives us 25. And of course, let's see, 45 minus 26 gives us 19. And if this is a quadratic pattern, we know that the sequence of first differences is arithmetic. So it tells us that the second common difference is 6. Now all we have to do, folks, is just to take back all of this. And how do we do that? We take 19 and we subtract 6. It gives us 13. So this tells us that between these two, we should have a 6. We do the same, 13 minus 6. It gives us 7, which is the very first difference. Right, and of course, between that and the next term, we should still have a 6. So, now we're looking great. So what are we going to do? We're going to say 26 minus 13. It gives us 13. So that's what we have there. Then we subtract 7, we get 6. So that's the first term. Of course, there are many ways of killing this cat, but our job is done. So we can just say, therefore, T1 is equal to 6. Right. And you can see that with all the hard work, we still get our answer. It's not a big deal. Of course, this has been a calculation of some sort, you know. But perhaps to just showcase that this has been a calculation, we can say this implies that T1 is going to be 26, which we're going to subtract 13, and subtract 7. And this gives us T1 to be essentially 6. Right. So we are good. Of course, I'm just prolonging the inevitable here. It's just for 1 mark. But I'm just trying to make sure that I adhere to the instruction that says calculate. So let's get to 1.2. 1.2 says determine the expression for the nth term Easy. We know that 2a is going to be 6. Therefore, a is 3. This would imply that 3 times a, which is 3, plus b should be 7. Therefore, b is minus 1. Nope, minus 2. Okay, so this also implies that a, which is 3, plus b, which is minus 2, plus c should give us a 6. Therefore, c is, now this is going to be 5. Therefore, t sub n is 3n squared minus 2n plus 5. Great. Now we just check if this represents our sequence. Let's look at the fifth term. So we've got 3 into 5 squared minus 2 into 5 plus 5. We get 70. Let's look at the third term. Just so we are sure this is good. We get 26. So this means we've got it. So we normally get a mark for these and then for putting it together. Nice and easy. So we've got 1.3. 1.3 says, which two consecutive terms of the first differences sequence will have a product of 7,735. Okay, so this is not a bad thing. So we know that t sub n for the first differences is a plus n minus 1 times d. So t sub n is 7 plus n minus 1 times 6. Now if we move quickly, t sub n is 7 minus 6 is 1. Therefore we get 6n plus 1. Okay. Now folks, this is the general term for the sequence of the first differences. Now what we're going to do, we know that we are being told that tn multiplied by tn minus 1. Remember, these are the consecutive terms. It's either we start with the one ahead or we start with the one before. It's not a big deal. We are just being told that this should be 735. Okay. Now tn is 6n plus 1 into, this one is basically perhaps the big bracket. It's going to be 6 into n minus 1 plus 1. This must be equal to 735. All right, let's deal with this. This is 6n plus 1 into, this is just going to be 6n minus 5 equal to 735. Right, so we FOIL. So obviously this on its own, perhaps we should put it in brackets. Now when we FOIL, this is going to be 36n squared. Then this is 30, minus 30 plus 6 is going to be minus 24n. And then this is minus 5 equal to 7735. All right, and then we move everything to one side. This is not 3 but 36. Okay, 36n squared minus 24n minus, this becomes 7740 equal to 0. Can try and divide by 36 throughout. What do we get? Not 36 but 12, the highest common factor. So this gives us 3n squared minus 2n minus, let's see what's that, 7740 divided by 12 is 645 equal to 0. Now we factorize. So this is going to be 3n, this is going to be n. Now I take this 645, shift and fact it, and see what that is. Shift, fact. So I'm getting 3 times 5 times 43. Okay, so how should this one work? 3 times 5 is 15, right? So this means these two must come together. This is 15 times 43. Now if I say 15 by 3, I get 45. 45 minus 43 gives me 2. So this is good. So this must be 15. This must be 43. The bigger product takes the middle term sign. And that's it. So from here we know that n should be equal to 15. Why am I choosing this? It's because n is an element of natural numbers. So we can't have a decimal. Great. So we can say therefore 7735 is the product of term 14 and term 15 of the first differences. Nice and easy. Nice and easy. So this is it, guys. It's very easy question that just needs one to pay attention, I guess. So I would say we get a mark for this. We get a mark perhaps for the substitution. And we get a mark for the 2 terms. That was the question. The 5th mark perhaps when we factorize. There are plenty of areas to think about, and of course, if you don't know how to factorize or you're not inclined to factorize, you can use the quadratic formula in here. All right, so we smile on, guys. We get our 10 marks in this question. Hey, boo. Okay, it refuses. We get our 10 marks, we move on. Question 2. And by the way, one can check, can look for term 15 here and term 14 and multiply them together and see if the answer is the same. So that sometimes is another way of checking if your doings are doing the things they're supposed to do. All right, so 2.1, we are told that the 5th term of a geometric sequence is 148. So this is T5 is equal to 1/48, not 148. Now what does this imply, guys? It implies that AR, because this is a geometric sequence, AR to the exponent 4 is 1/48. That's easy. Can leave it here. It's not a big deal. So this is equation 1. It's going to be simultaneous equations. And we know that also T9 is equal to 1/768. Okay? Where R is negative, so this is important. Now what does this mean? AR to the 8 is going to be 1/768. Okay, but now we can use our gymnastics and say this is the same as AR to the 4 times R to the 2. This is equal to 1/768. Okay, so playing, and what do we know? We know who this guy is from 1 above. So we just move nicely. We know that this is 1 over 48. R squared equals 1 over 768. If we divide by the 1 over 48, we get R squared equals, let's see, 1 over 768. That divided by 1 over 48. This gives us a 1 over 16. Okay, so this implies we take the square root. We take the square root. Now what happens? We know that R, it would have been plus or minus, but we're going to take the negative one because of the statement over there. So square root of 1 is 1 divided by square root of 16, which is 4. So if R is 1/4, so what is the story? We want the first 3 terms of the sequence. So that's not a problem. So we want term 1. So let's see. So we can say sub R into 1, because what we need is to find the A value. So this means we've got A into minus 1 over 4 to the exponent 4. Ish, why is this thing big now? Equal to 1 over 48, right? Right, so this implies that our A is going to be, let's see, 1 over 48 divided by minus a quarter to the exponent 4. So we get 16 over 3. Nice and easy. We can say, therefore, the geometric sequence is, the A is 16 over 3. The second one, we just multiply it by minus a quarter. It gives us a minus 4 over 3. And then the next one, we then multiply it again by minus a quarter. We get a third. And it goes on. That's all we needed. Great, so let's see, this was the third term. Let's look at the fourth. Multiply by minus a quarter. We get minus 1 over 12. That's the fourth term. Let's look at the fifth. Multiplied by minus a quarter. We get 1/48. So this is good. All right, so that's it, guys. We've answered the question. Nice and easy. So how many marks was this? 5. Okay, so we're going to get our mark over here, and we get our mark when we substitute. Is it? No, we get our mark, I think, when we substitute. That's 2. We get our third mark. Yes. Fourth mark. Yeah. Okay, so these two we can combine. It's not a big deal. So we've got 1, 2, 3, 4, 5. Looks all right. Next question is 2.2. 2.2 says we've got a sigma of 2p to the exponent 1 minus k, starting from 0 to infinity, where p is not equal to 0. And we need to find the values of p if it is given that the sum to infinity is 12,5. Okay, so that's not a problem. We take what we are given. So the sigma is starting from k equal to 0 to infinity, 2p to the 1 minus k. We always expand. We put a 0 there, we get a 2p. Sigma means plus. And then we put a 1 in there, we just get a 2. Plus, just need 3 terms. We put a 2 in there, so we get a minus 1. So we get a 2 over p, right? Yes. And then it continues to infinity. So all we want is to say r is going to be 2 divided by 2p, where the 2's will divide to 1. Therefore, our r is equal to 1 over p. Okay, and now it makes sense why p cannot be 0, because we cannot divide by 0. Right, so this is good. Now, we want to find the values of p. We know that the sum to infinity, the sum to infinity is a over 1 minus r. So this implies that we've got 12,5 equals a, this is just 2p, divided by 1 minus 1 over p. So if we simplify, we've got 12,5 equals 2p divided by p, there is going to be p minus 1 all over p. Now when we sort this out further, this is 12,5 equals, we flip this, we're going to get 2p squared divided by p minus 1. Now this is over 1. We cross multiply. We will get 2p squared. Then we move this in, it's going to be minus 12,5p. And then it's going to be plus 1 equal to 0. Is that so? Not plus 1, but plus 12,5. Remember that 12,5 multiplies here. This is initially positive and negative. When we bring into the other side, that one which was positive becomes negative and the negative one becomes positive. Question is, can we factorize this? Maybe, maybe not. Let's try. So let's see, if we write 12,5, that's 25 over 2, right? And then we shift and it won't heaven can't why it's telling me errors. Let's try, guys, but if you're not confident, sometimes there's kinds of decimals where you just have half of something. You actually can. Let's put a 2 there, 2p, so both of these must be negative. Now let's find out, how do we get there? How do we get there? Look, 12,5 is 10. Let's see. 12,5 is basically 10 plus 2,5. Now, if I've got 2 and I have got 10, how do I generate 10? I multiply it by 5, isn't it? And then I must have 2,5 here. Is that so? Let's see, what is 5 times 2,5? 5 times 2,5 is indeed 12,5. That's good. So obviously, you may not need to do what I just did. But sometimes, you know, when the maths is flowing, it just flows. So this tells you and I that P should be 2,5 divided by 2. Let's see, what is that going to be? It's 5 over 4, right? Right. Or P is going to be equal to 5. And this looks okay because these are rational number solutions. But again, once you've got like halves of certain numbers, it's much easier to play with them. But hey, don't try your luck too hard. What were we looking for? The values of p. So there's 2 of them. So we're going to accept both. Great stuff. So let's have a look, folks, and see what is cooking. Let's see how many marks were we supposed to get. 5. Okay. So usually the expansion is usually rewarded, the value of the common ratio, yeah? The substitutions 3, 4, and 5. Okay. I think that's it. Smile our way forward. So this is 10 marks. So guys, any one of you who wrote this paper must have been smiling throughout, isn't it? So question 3. Question 3 says, after undergoing knee surgery, Patrick had to return to his running program gradually. His physiotherapist advised him to do it in the following way. He has to run daily, yes. In the first week, he must run 6 minutes per day. Okay. In the first week, every day he runs 6 minutes. Okay. Very important. This is the first week. Okay, guys, let's put some sense into this. Every week thereafter, he must increase the time per day by 3 minutes. Okay. Now it says during which week in his program will he be running 60 minutes per day? Okay. Now this is good because this is per day. So we don't have to worry about multiplying, the number of minutes per day for the entire week. Now we just have to take it easy. Of course, we've done the geometric sequence and its convergent series. We've done quadratic. So this can only be arithmetic, isn't it? So 3.1. We know that t sub n is supposed to be a plus n minus 1 times d. So we're being told that this is the situation. And then a is 6 plus n minus 1. This is going to be d, which is supposed to be 3 minutes. So this is very easy, guys. The increment is by 3. We started from 6 per day, and this is per day again, so this is good. So let's move on. So we've got 60 equal to, this is going to be 3 plus 3n. So this implies that we've got 3n is equal to 57. Therefore, n should be 19. Let's see, 57 by 3, yebo. That's 19. So we can say, therefore, he will be running 19 minutes per day during the 19th week. No. He'll be running what? 60, not 19. 60 minutes per day during the 19th week of his program. Right, of course, guys, you try your best to answer fully, because we use these mathematical gymnastics to answer some serious real-life problems. Now, that's fine. The substitution is good. The n is good. How many marks? 3. Okay, perhaps. I don't know, whatever. Noting that A is that, or whatever you want to call it, it is what it is, guys. Fact of the matter is the work is done. So 3.2 says calculate the total number of minutes he would have run by the end of the 19th week. Okay. Now what does this say? Calculate the total number of minutes he would have run by the end of the 19th week. Okay. So now this one is a bit silly. Let's see. We will have a sum formula, right? S sub n equals n over 2 into A plus L. Right. So we've got S. Now, this question for me, calculate the total number of minutes he would have run by the end of the 19th week. Remember, the 19th week has how many days? Well, 7 days, because a week is 7 days, isn't it? Okay, all right, okay. So we need to be careful here on how we're going to do this. We need to be very careful. Of course, this sequence is somewhat repetitive. There are some spots that keep repeating, so I think we are at liberty to say this is going to be 19 of these divided by 2, but A is going to be 6 times 7. Okay, this is 6 times 7, which gives us 42. Plus, of course, you may want to showcase this, that, of course, this is 6 times 7 plus the last term here. It's going to be 19 times 7 as well. Not 19, but 60 times 7. So 60 times 7. Right, so this is 60 times 7. Right. Now, I just want to check something. Let's say in the first week, because there's 19 weeks here, in the first week, the total number of minutes is going to be 6 by 7. The second week, just want to check if at all this is arithmetic. This is going to be increased by 2, so this is going to be 9. By 3, sorry, it's going to be 9 times 7. That would be 63. Okay, 63. All right, so I just want to check something. By the third week, this would be 12 by 7, which would be 84. So this one is not an easy question. Now let's see, is there a common difference between this? 84 minus 63. We get 21. Now let's say 63 minus 42. 63 minus 42. 21. So this is indeed arithmetic, so we are good. So all of these weeks, we're just going to put them together like that. It is still arithmetic, and there's going to be 19 of these weeks. So this is good. Now let's see. Therefore, we can see that S19 is going to be, we've got 19 over 2 into 6 times 7 plus 60 into 7 So we get 4389. So we can say, therefore, he would have ran. He would have ran. Is it ran? He would have ran. He would have run. He would have run 4389 minutes by the end of the 19th week. Okay, so obviously you need to know that here we're just combining all the minutes per week because there was consistency. So these are some of the sequences where there's some repetition within the week. So I hope that is clear. So let's see, we get our marks. How many marks was this? 3. So we can say this is a mark. The entire substitutions, I suppose. And all of these calculations, this and that, perhaps. Or we can easily say the formula, we're not really fooled by it. Those two are good enough in the answer. And of course, we must make an effort in answering the question properly. A calculation was not an end in itself. It was rather a means to an end. So we smile forward, folks. We are doing great. So let's get to functions. Nice and easy. So question 4. So question 4 says we've got f of x equals 2 over x plus 1 and g of x equals k to the exponent x, and point 2:9 lies on g. Okay, determine the value of k. Easy. So we've got 4.1. We know that g of x is k to the x. Through the point 2:9, we know that 9 is going to be k squared. So this means 3 squared is going to be equal to k squared. Therefore, k is going to be 3. Why am I choosing the positive answer? Remember, with exponents, you can consider both the positive and negative. It's because the base is either less than 1, greater than 0, or b must be greater than 1 for that to be called a function. So b cannot be negative. So that's why we're doing what we do. So it looks like for all our troubles, we don't get much. Should have been 2 marks though. 4.2 says, write down the equations of the asymptotes of f. Well, the horizontal one means x is equal to 0, which is the y-axis, and then y is equal to 1. Nice and easy. So 4.3 says, determine the equation of the inverse of g in the form. Okay, we know that y is going to be equal to, now that we see k is 3, it's going to be the log of x to the base 3. Nice and easy. So we get 2 marks for the answer. But if you want to go the long route, be my guest. At this point, we don't have time for explanations. We are moving. Now this says, sketch the graphs of f and the inverse of g on the same set of axes, clearly indicating all the asymptotes and intercepts with the axes. Now, we can see that with f, we are going to have no y-intercept because x cannot be 0. So we won't have a y-intercept. Okay, that's number 1. But an x-intercept is possible. Okay, cool. So let's look for the x-intercept. So f of x equals 2 over x plus 1. We can say for x-intercept, it will be such that 0 is 2 over x plus 1. This implies that minus 1 over 1 is equal to 2 over x. From here we can see that x is going to be minus 2. Because if we cross multiply there, it's going to be minus x equals to 2. We solve for x. So we can say therefore the x-intercept is minus 2 and 0. Okay, that's what we need. Then we go and do the sketch. Okay. So there's our sketch. Right, the origin. Now if we start with the hyperbola, it's going to be in the first quadrant and third quadrants. Let's start with the asymptotes. Say this is the horizontal asymptote. Okay, so we break it up. Nice. And now, after we break it up, what do we see? Obviously, this one is also an asymptote, but because it's the axis, we're not going to change it and make it dashed at all. All right, so that's fine. Now the graph should be here. Right? Okay, so that's the graph of f. We can label it here that this is f and this is minus 2. And we know that this is 1 where the asymptote cuts. And that's it for graph of f. It's sorted. Now, the graph of g will not respect the asymptotes per se of this one. So this one is going to do stuff like that. Right. And where it cuts, it's going to cut at 1. Okay, great. So that's it. Perhaps this one is not quite convincing. I don't like the shape. When is this graph going to be 1? When the x value is 3. So if it cuts here, we expect it to curve nicely like that, so that it perhaps cuts at 3. Yep. Yeah, boy, yes. At least I want it to be at 3 over there. Okay. Not a problem. So this is the inverse of g. Nice and easy. So guys, you get your marks. 5 marks. So this is going to be a mark for the x-intercept of the inverse and the shape. That's 2 marks. Then it's going to be a mark for the x-intercept for the f function. And the shape, that's another 2 marks. And then 1 mark for the asymptote of f. And of course also the asymptote of g, which becomes the y-axis. So those are just pretty much coincidental, I guess, or they occur simultaneously. Okay, that's fine. Now we get to 4.5. It says for which values of x will f of x, so this means the y values of f multiplied by the y values of the inverse, be less than or equal to 0. Okay, this can happen when one of them is 0, but will this work? Now let's see if we can do this. Let's just do a vertical line. Remember, we need to compare them for the same x value. Okay, so if we come from this end, we can see that the inverse function is not there, and it's not there, so we cannot assess this side at all, because the graph of the inverse is undefined on this side. So let's look here. They both do not occur on this line, and then if we move slightly, yes, we get a positive multiplied by negative, that's less than 0. And then if we move over like this, the other one is 0, the other one is positive, it gives us 0. Right. Now when we move past this, they are both positive, so the product is greater than 0. So this means our issues here only take place in between. Our issues only take place here. Right, so this is the interval that matters. Okay, good. So let's go for it. So 4.5. We know that, well, x must be less than 1. In fact, can be equal to 1, but it has to be greater than 0. Nice and easy. We get a mark for that. Okay, correct inequalities versus correct values. Nice. So 4.6 says, determine the x-coordinates of the points of intersection between F and its axis of symmetry with a positive gradient. Okay, so we know that if we were to draw our axis of symmetry, it has to pass through there, sort of. Right, this would be the axis of symmetry for F. Right, with the positive gradient. So this means we want to know about those points. Well, we know that from theory, these points are such that 1 is going to be the square root of a plus p into the square root of a plus q. That's the first one, the positive one. The second one is going to be minus the square root of a plus p into minus the square root of a plus q. So if we know that, we can just go straight to it. So this is going to be the square root of 2 plus nothing. Okay, this is just the square root of 2. Because there was 0 there, then this is going to be the square root of 2 plus 1. That's the one part. And the second one is going to be minus the square root of 2 and minus the square root of 2 plus 1. Okay, so that is essentially what we have. But for those who cherish simultaneous equations, because you've got trust issues or perhaps you were never shown this, you would easily say f of x is equal to the axis of symmetry. Let's just do it. Okay, we can easily write it. F of x is going to be equal to mx plus c. We know that it's going to be like that. So this is 2 over x plus 1 equals, this one is going to be x plus 1, isn't it? Because this becomes its y-intercept at 1. So this is good. Multiply everywhere by 2. What do we get? Get 2 plus x equals x squared plus x. So the x takes care of the x. When we move around, what do we end up with? X squared is equal to 2. Therefore, x is going to be plus or minus the square root of 2. Those are the two x values. And then when we substitute into 1, we know that y is going to be equal to the positive root x plus 1, or y is going to be minus the negative root 2 plus 1. Therefore, the points are going to be this positive square root of 2 is 2, root 2 plus 1, and the other one is going to be minus the square root of 2 into minus the square root of 2 plus 1. As you can see, we still win. There's nothing wrong with the approach as long as it is done. Once the question says determine, we can do whatever we choose. So obviously, guys, you get your marks there, maybe the extra mark for everything, at least for 3 marks. If you present 2 things, we are good. But if you chose to do this, you'd get a mark for this determination, get a mark for the x, get a mark for the y values. But we still have to present these as ordered pairs. Alright guys, we smile our way forward. By the way, in the next few days, I'm going to give you guys a comprehensive review of the hyperbola so that you can understand it very well and also understand its utility. Some of you keep on making noise that we study these things and we never use them. I'm going to show you exactly where they are used and why they are used like that. Anyway, so that's it for that question, guys. We have sorted it out nicely. Let's get to question 5. So question 5 says, sketched below is the graph of f, which is the parabola which with x-intercepts at 2 and minus 4. So we can see that. And point A is any point on the graph, which is what we see there. Now it says write down the coordinates of the image of A after reflection in the axis of symmetry of F. Now folks, we know that basically the axis of symmetry is going to be the average of these two. Now my students know this. We discussed it before the exam. So if any one of you wrote this exam, perhaps you would have won. But again, it depends on whether you are clear about these graphs or not. I will do some very comprehensive videos on these functions: the hyperbola, the exponential, the parabola, and the straight line, because these ones students tend to just know how to manipulate, but they never really understand why these things are even meaningful. Of course, some of the sequences and series questions, as you can see, are actually already being applied. You know, that person who was running, that's already an application of a straight line function, because that's what it is. Anyway, let's just get to this one quickly. So we've got minus 4 plus 2, which we divide by 2, we get minus 1. So we literally know that our axis of symmetry is going to be at 1. So this is the x coordinate of the turning point. Right. So this is at minus 1. So we can already see that, okay, for us to know what to do from the axis of symmetry to that point, how many units is this? This is 4 minus 1. This is going to be 5 units. Now we know that we're going to move the same units back to its mirror image over there. So this should be 5 units too, because the axis of symmetry will cut these points such that the line joining them is perpendicular to the axis of symmetry, and the distance from that point to the other, the distance from that point to the axis of symmetry and from the axis of symmetry to the other point is the same distance. Now minus 1 minus 5 is going to give us minus 6. But now the y value is going to be the same. So we're going to write here 5.1 a prime is just going to be minus 6, and what was the y value? 8. Leave it like that, straight up. This question said write down, so answer only. As you can see, though, it didn't just come. We had to work it out. Now we need to show that a is a half, b is 1, and c is minus 4. No problem. So we know that our f function is in the root form. So this is x minus the first root, x minus the second root. So this implies that our f is a into x plus 4 into x minus 2. We plug in the point a, which is 4 and 8. So 8 is a into 4 plus 4 into 4 minus 2. So we've got 8 equals, this is 8 times 2, that's 16. A, and we can see that a is going to be a half. We got it. Now we go back, say then f of x is equal to 1/2 of x plus 4 into x minus 2. We FOIL it out. So this is 1 over 2 into, this is x squared, right, plus 2x minus 8. And so we can conclude that our f function is a half x squared plus x minus 4. Therefore, a is a half, b is 1, and c is minus 4. Done. Okay, we've done quite a lot of work on this. It should not be a problem. So we're only getting 3 marks, but again, the answers were volunteered. So this piece right here is more important. And essentially substituting the point is key. And then writing the equation in the expanded form or working it to that extent. That's where we get the 3 marks. We're not going to get a mark for each individual A, B, C, because we're already told what they are. We just have to show that they indeed are so. Right, so that's 5.1. Sorry, 5.2. Now let's look at 5.3. 5.3 says determine the values of d such that, okay, what is this? Such that this will have 2 positive real roots. Okay, good. So if we look at d already from here, it's where x was meant to be. So once we add d, it means it's a horizontal shift, either left or right. But now what doesn't make sense is the rest of this thing. So we need to write it in standard form. So we've got 1 over 2 into x plus d all squared plus x equals 4 minus d. Therefore, what we are looking for is a half of x plus d all squared. Plus we move everything, so it's going to be x plus d. So we want it there. Then minus 4 equal to 0. So we can already see that this is nothing but the x-intercept of this function when it is shifted to the right by d units. Because we cannot shift it to the left. Why? Because if we shift it to the left, then the roots will become negative. So if we can just map this graph. So there we go. If we shift it like this horizontally, see the roots are going to be negative. But if we want them to be positive, we have to shoot it this way. But of course, that's the smaller limit that it has to go. But now when it's 0 and this, we just have one positive root. So we want them to be both positive. So this means we first need to find out what would be the distance from that root to the origin. That's the first thing that we need to know. And from that, we know that if we go slightly higher than that, then the graph will have shifted such that both the roots are positive, and this is what we want. Okay, no problem. So we can say here, therefore, this implies that minus d, because d must be a negative number, must be greater than how many units? From origin to minus 4 is 4 units. So we know that this has to be greater than 4 units. So therefore d must be less than minus 4. Obviously we know that d has to be a negative number, but a number that is less than minus 4, so that it can then move the graph to the right by more than 4 units. So that's it, guys. Nice and easy. So obviously writing it in that manner and perhaps that interpretation, the answer, or one may consider the writing and 2 marks for the answer. It is what it is. All right, guys, we smile forward. So we've got our nice 8 marks there. Easy stuff. Question 6. Question 6 says the graph of the inverse of f is minus the root of 12x, where x is greater than 0. And this is sketched below. Okay, now the point P, 3 is to minus 6, lies on the graph of the inverse. Now it says determine the equation of f in the form y and indicate all restrictions. Obviously, guys, we know that if everything is under the square root, the original function must have been, you know. So this is 6.1. I know that f of x should be 1/12 of x squared. Now we can just write the restrictions. What should the restrictions be? Now, if the inverse is like that, remember the restriction on the, how do I put this? The restriction on the domain of the inverse becomes the restriction on the range of the original. Right. But now the only problem is that with this kind of a situation, we're going to run into problems because the range for the original is positive for both parts. So which part do we know? We know that if this is the case, if this is the function, we are going to take it and roll it around. Son, konje ayivumi. I won't be able to. It's not going to work in my favor. Okay, but we know that this graph should show up here, like so. Right? It should go like that. So now what should the restriction be? Well, in this case, we don't have a choice but to accept we don't have a choice but to accept that x must be less than 0. Must be less than or equal to 0 for this one. That's it. That's just the best we can do here. I don't think there's much. Of course, guys, you would get perhaps 2 marks for the answer and for the restriction. I don't see anything else that we can do. Right. Now let's see, what is the story here? Some of you may want to perhaps pursue this question algebraically, which is not a problem. So we know that our f, by the way, we were told y, we should not write f here. So we know that f of x is going to be, we swap y for x, right? Now, when we square both sides, we end up with x squared is equal to basically 12y. Then we solve for y. It's going to be 1 over 12 x squared. But remember, we need to decide now, what should this thing be? X must be less than or equal to 0, because that would be the reflection of that whatever. Okay, so these things can be quite challenging if you don't know them graphically, but yeah, you do your thing. So the swapping, the answer, and the restriction. Okay, easy. So let's see, 6.2 says, sketch the graph of f in your answer book. Indicate any intercepts at the axis and as well as the coordinate of one other point. So if we take this point P, it's going to be somewhere there. So that point P, we swap these two, is going to be -6 and 3. So this is the graph of the inverse. No, this is the graph of f, excuse me. So I'll just say C sketch. Of course, you may have been provided a grid. If not, then you provide your own. Okay, 6.3 says, describe the transformation from the inverse to G inverse if G of x is the positive square root. So obviously we just reflected it vertically. That's a vertical reflection, so that the graph appears on the other side, like so. Isn't it? Something like that. So that would be the G inverse. Of course, you don't have to draw this. I'm just showing you guys how it would look. So this is a vertical reflection. So we can say G inverse is a vertical reflection. Let me write it better. Is a vertical reflection of F inverse. Or one can say it's a reflection about the x-axis. So we get our 7 marks and we smile on, guys. There's not a lot to do. We just move. We smile towards trigonometry. So question 7. Let's see. It is given that a cos 28 equals b. Well, we have to express the following in terms of a and b without the use of a calculator. So that's easy. 7.1, we've got a cos 28 degrees equals b. Therefore, cos 28 degrees is going to be b over a. Now we know that 28 degrees is an acute angle in the first quadrant. So we don't need to be invited as to where this is. 28 degrees. That's y, that's x, that's the origin. Now, we need the complement of this angle. 28 to 90, that should be 62. Right? Yes. And then, of course, guys, cos is adjacent of a hypotenuse. So this means we need y. So x squared plus y squared equals r squared. From Pythagoras, so this is b. Y squared equals a all squared. Therefore, y is going to be the positive square root of a squared minus b squared. So that's a difference of 2 squares. We are choosing the positive one because this is the positive y-axis. Nice and easy. So you do this, guys, as soon as you can. You don't wait for a direction to do so. Now we need to deal with cos of minus 28 degrees. This is the same as cos 28 degrees, which is going to be b over a. Easy. So the reduction and the answer. Right, 7.1.3. We've got sine of 118. This is the same as sine of 180 degrees, I believe, minus 62. Right? 180 minus 62, yebo. Can you see, knowing the complement there was important, so this is going to reduce to sine 62 degrees, which is just going to be b over a. And we saw that this was the complement of 28, so cofunctions are equal in this case. So the reduction and the answer, nice and easy. So we've got 7.1.4. Oopsie, incorrect labeling. So be careful, guys, don't get caught pants down. Doing all the right things, but incorrect labeling can catch you. So we've got sine 56 degrees. So this is the same as sine 2 times 28 degrees, isn't it? It's a double angle. So this is 2 sine 28 degrees cos 28 degrees. This is 2 into sine 28. It's going to be this square root all divided by a. Cos 28 is b over a. So if we sort it out, we're going to get 2b root a squared minus b squared all divided by a squared. And there's no further simplification to do here. And the good thing is that the denominator is already a rational number. Remember, a perfect square is a rational number. Great. So how many marks? Well, perhaps we get a mark for this, the expansion, and the final answer. Nice and easy. Right, so last question, 7.1.4 says we need cos 14. Cos 14 is basically half of 28, isn't it? So 28 is the double angle here. So we can start with cos 28 degrees is the same as cos of 2 times 14 degrees. Now we can decompose it however we choose. This is going to be, okay, maybe let's write it as an equation because we won't be able to solve, right? We won't be able to solve. This is the same as cos 2 times 14 degrees. Or we can actually stop there and just keep that in mind. This is 2 cos squared 14 degrees minus 1. Yeah, I think this one makes sense. And then we make cos squared 14 degrees, the subject. So we're going to have cos squared 14 degrees is going to be cos 28 degrees plus 1, all divided by 2. Then this implies that cos 14 degrees is going to be the square root of, what was cos of 28? It was a over, it was b over a plus 1, all divided by 2. Okay, now let's see, what do we get? A times 1, that's a plus b, that's going to be a plus b. So let's do this. This is going to be the square root of a plus b all over 2a. So that's the best simplification we can do here. Nice and easy. All right, guys, so this is cool. How many marks? 3. Yeah, I think for this, we get a mark. And we get a mark for that. And maybe for that too. It's otherwise not a big deal. 7.2. Now I need to simplify to a single trigonometric ratio. Guys, I'm not 100%, eh? These days I'm not well at all. I don't know what's wrong with my hip, but it's killing me. And this thing keeps on happening every year. So I'm not sure what is happening. My neck sometimes, but this time it was the hip and the neck. So I don't know what's up. Because everything checks well, but I have a pain that just doesn't give me a chance. You know, doing these videos is just a way of distracting myself from this, but oops, it's just not nice, eh? Anyway, guys, we've got this expression to simplify. So we go for it. So we know that we're going to have 2 into, this reduces to just minus cos x all squared minus 1. This one is an acute angle. So we'll leave it as cos 67 for now. Remember, don't rush certain actions. We look at this one, we don't see any reason to manipulate it as yet. Times the tangent is sine 23 degrees divided by cos 23 degrees. Now we can already see that that cos 67 we can change to cos of 90 minus 23 degrees, because we can see that's a cofunction of 23. Right. Is that so? Yes. Okay, so let's move. Now, sometimes doing rough work, guys, is important, because you see, you don't want to end up, you know, scraping this and all that. You just, once you do trig expressions, you need a rough work page. You work on that first, and then you transfer all the correct steps so that you don't end up with a dirty thingy there, because it can be very overwhelming. So of course, guys, once we sort this out, we're going to get ourselves a 2 cos squared x minus 1 times, this simplifies to sine 23 degrees all divided by, now we can see that this looks like that. If we take minus 3 out, we end up with 1 minus 2 sine squared x, right, into sine 23 degrees over cos 23 degrees. Great stuff. We sorted out. That's a compound angle identity, sorry, double angle identity for cos. This is cos 2x, right, times sine 23 degrees, all divided by, this is minus 3 into, this is still cos 2x into sine 23 degrees over cos 23 degrees. We know that this one is going to take that, and this one takes that. And what do we have? This one is going to flip into the numerator, so this is going to be minus a third of cos 23 degrees. Okay, so that's it. Now, folks, sometimes you may wonder, is this correct or is it not? Sometimes I just choose a value for x, and then put that on the calculator and see if I'm going to get the same answer as when I evaluate the final answer. But of course, this can be a bumpy road. So 2 into cos 180 plus 2, and then we square it, minus 1, and then we close it, we multiply this one by cos 67, all divided by 6 into sine of 2, all squared, minus 3 into the tangent of 23. Right, so I'm getting an answer of minus 0.3068, and then of course other numbers. Let's see when we evaluate this. Minus 1 over 3 into cos 23. Get the same answer, so this means we are good. We've done it. We have done it. So it helps to check, guys. There's no excuse in presenting incorrect answers here. Right, when we use our identity there and identity over there, that's 3 marks. The 10 identity 4, and factorization 5, changing this 6. So that's essentially how we score the marks here. There's a lot, but yeah, this could easily have been 7 marks. So let's look at 7.3. 7.3 says, prove the following identity without the use of a calculator. Okay, you can choose here the left-hand side is sine 45 degrees plus theta minus cos 45 degrees plus theta. So this is going to be sine 45 degrees cos theta plus cos 45 degrees sine theta minus this becomes cos 45 degrees cos theta. The sign goes to minus sine 45. Yikes. Okay, minus sine 45 degrees sine theta. This is 1 over root 2 cos theta plus 1 over root 2 sine theta minus 1 over root 2 cos theta plus 1 over root 2 sine theta. Now this and that go away. So we end up with 2 sine theta over root 2. Right? Right. Okay, that's fine. It doesn't look like anything of what we want. So we take the right hand side and sort it out. So we've got root 2 sine cubed theta plus root 2 sine theta cos squared theta. So if we take root 2 sine theta as the highest common factor, we end up with sine squared theta plus cos squared theta. So this is root 2 sine theta into 1, which is root 2 sine theta. So this means we can rationalize here. And what do we end up with? We end up with 2 root 2 sine theta divided by 2. And the 2 takes the 2, which ends up as, okay, it's going to be a bit ugly. Let me just commit to this. Root 2 sine theta. Now we can see that essentially the left hand side is equal to the right hand side. Unfortunately, these two are terrible. As you can see, one has to work with either side until they look the same. But I know there is a way of forcing one side to work straight into the other side. But yeah, for the sake of this video not being longer than it's necessary, we just stop here. So we're getting 5 marks here. So obviously this is a mark. And when we use an identity, it's a mark. When we factorize, that's a mark. 3. When we use our special angles 4 and both the expunctions for sine and cos, that's 5 marks. That's exactly how I would go about it. So we take these 21 marks and we smile forward. Question 8, trig functions. Okay guys, I've taught you these nicely. So those of you who really made use of my channel, and I in KZN, there's not a single topic in trigonometry I didn't teach you guys. So this was perhaps a walk in the park for some of you. But for those of you who wait until things hit rock bottom, you sweat for no reason. Okay, in the diagram below, the graphs of f equals a sine x. Now we know that f is this graph, and this is typical of the sine function, but we can see that the maximum has gone to 3. So what does this tell us? It tells us that the maximum value there is 3. And this means the minimum value there is going to be minus 3. Okay, so that's all, and in fact it just tells us that this is the absolute value of whatever we have, maximum or minimum. So this is going to be minus 3. No, it's going to be 3. Great. Again, to find the amplitude, you take the maximum, you subtract the minimum, you divide by 2, you still get a 3. Now 8.1 says determine the values of A and B. So A, we know that at determination, it's an answer only. But let me show you how it's done. Take the maximum minus the minimum, and you divide this by 2. Therefore, A is 3. So that you don't end up in trouble for not doing the right thing. B, let's see. B, this is just 2 cos what, so this means this is a 2. And it also means the minimum value for our cosine function is going to be at -2. So essentially, let's see. Did we expect the cos of 0 to be 1? Yes, but now it goes to a maximum of 2 because of that. And at 90, we expected an x-intercept, and we see it there. So to get B, we know that B is going to be the original x-intercept, which is what we know. And what do we see now? In the first quadrant or so, it's still the same. So this means B is just 1. So the examiner is just playing with our heads, because obviously the graph is behaving as expected, except that the amplitude has changed only. The period is still 360. So this means it's the same thing, but you can use certain identifiable points like an intercept, that the old divided by the new will tell us the function, the frequency that the graph is moving at. Obviously, you just get a mark for each. Answer only is good enough, but it helps to know how to arrive at these, because sometimes, oopsie, you cry and cry and cry. Now determine the values of x in this interval, -180 to 0. So we're moving from here all the way to here, where f of 2x is less than and equal to 0. Okay, all right, okay. So obviously, guys, if this is the case, when we multiply this, we make the period a bit shorter. What's going to happen? Now this is going to divide such that this part is going to be over here at -45 degrees. The graph would be sitting over there, and then it will cut, and at 135, which is somewhere there, -135, the graph would be right at the maximum, and then it would sit. So we'd end up with a graph like this. Okay, don't worry about the look at the moment. All we care about is whether it does what we want. So we'd end up with the graph. This is going to be the graph of f of 2x. Now if we look at that, we can see that when is it less than or equal to 0? Right here in the middle. This is where it's going to end. Okay, right, and I'm going to show you how to do this without needing the sketch. So we know that x should be less than or equal to 0, but greater than or equal to -90 degrees. And of course, we get our 2 marks. Nice and easy. Now, for those of you who probably wouldn't think of the graph, but you want to use your logic as much as possible, you will just write the original. When is f of x less than or equal to 0? We write this is going to be x less than or equal to 0, but greater than or equal to -180. Right. Now, once you see that 2, we know that f of 2x less than or equal to 0 is such that x less than or equal to 0, we divide this one by 2, must be greater than -180 degrees divided by 2. Therefore, f of x must be less than or equal to 0 degrees. It still doesn't change, greater than. This one becomes -90 degrees. So Again, folks, understanding these functions, in such a way that you don't sweat, as you can see, logically, you don't need to draw the graph, but sometimes if you are strong on the graphs, like you can see here, you get a quick answer without struggling. This means you must be comfortable with the graphs. So there's no excuses, guys, you can put forward. So you can see you don't even need the sketch if you know what to do. That's all I'm trying to highlight. I'm trying to highlight the fact that you don't need the sketch. If you know what is happening, you can work it out even logically or algebraically. So the key here, if you want to just look at what you have, you know that each one of those points will be divided by 2, because everything is going to change such that an original point is divided by 2 to get us to the new point that would behave in a similar manner. Okay, so that's it, guys. So in essence, you get your marks here. Nobody cares about how you did it. Okay, that's fine. Now let's move on. Next question, 8.3 with 8.3.1. Now it says here, points P and Q are 2 points of intersection of F and G. Calculate the x coordinates of P and Q. So that's easy. So this is when 3 sine x is equal to 2 cos x. Okay, here we can divide by basically 3 cos x. Remember, in math you divide by anything you want to eliminate, and when you do that, life becomes nice and easy. So this means you've got 10x is equal to 2 over 3. Now with 10, we know that x is going to be the arctan of 2 over 3 plus k times 180 degrees, where k is an element of integers. Therefore x is, let's do it. So arctan of 2 over 3 gives us a 33.69 degrees plus k 180 degrees, where k is an element of integers. You can say therefore x at P is equal to, and x at Q is going to be equal to. Now obviously we know that this is the first quadrant, so that should be exactly this angle. So x at Q is going to be 33.69 degrees. Okay, when k is 0, and we know that P now is a point there. Okay, let me remove this 135. So we want to know what is that value there. Great, so let's find out. What should it be? Now we say k is minus 1, so this is minus 180 plus 33.69. This gives us a minus 146.31 degrees. Okay, that makes sense. So that's it. We are done. Nothing difficult. Just knowing general solutions is the way to go. So getting 4 marks, we get a mark for this, this, and for the 2 answers. Perfecto. Langraba. This is 3.2. So we know that we're looking at minus 146.31 degrees, and this is 33.69 degrees. Okay. 8, 3, 2 says, hence determine the values of x in the interval -1, 8 to 180, for which 10 of x is greater than 2/3. So we know that essentially the value of 10 being 33,69, this is when 10 of this angle is 2/3. So it is here and there. So 10 of x is going to be 2/3 at those points. But now, what do we know? We know that we know that 10x is basically sine x over cos x. Of course, we want this to be greater than 2/3. But now remember, it is 2/3 at those points. If we look at these points, you will appreciate something. Let me do this. Let me do this. Of course, if you follow this, we start from where they are equal. And then we come here. These are some of the areas to consider. Now guys, it helps to really know your craft, okay? It really helps. We can consider this. If you don't know your stuff, you will struggle to survive, okay? Again, we want to consider the part when they are equal. So use your ruler to move around like I am showing you guys. These are the important areas to consider. Now let's check what's cooking here. If you look at before this interval, you will already see that the sine function is on top, right? But as we move from left to right, it's decreasing, while the cosine function from its minimum is increasing. Now, if you've got a decrease in the numerator and an increase in the denominator, this means this thing is going to be less than 2/3, right? So that is not going to work. We don't want that part. When we get to this portion, we'll see that the sine function is increasing up until it is 0 from here. And it's also, the cosine function is decreasing to its minimum. All right. So basically, this segment is good because if the numerator increases and the denominator decreases, it means this is definitely going to be correct, because first it started being equal. So the moment the numerator increases, we don't care by how much, but the denominator also increases. At this point, we don't care by how much. We know that that ratio is going to be bigger than, the 2/3, okay? Excuse me. Now, when we get to this part, well, do we want to include these? Well, we can include them because even here, but anyway, here it's going to be dangerous because 0 is not included. So that one is 0. This one is a minimum. So 0 divided by any number is 0. So we will not include. Okay. Now let's go on. If we look at this one, we will see that this graph is increasing while this one is also increasing. So they are both increasing. At this point, we cannot tell what is going on, okay? We cannot determine what would be the case, because if this is increasing and that is increasing, it's not easy to tell. So most likely the ratio is going to be way less, okay? And then we get here. Again, we cannot divide by the way, we cannot divide by 0, not that it's 0. We cannot divide by 0. Okay, so here's the thing. Guys, this guy. What sayest thou? No, man, this is the sine function. So if the sine function decreases, right, this cannot work, is it? Angizwanga kahle ukuthi ngithini la. Did I say something? Sine is on top, right? Now from here to there, right, sine is decreasing and this one is increasing, so it's not going to work. Here we still have sine decreasing and that one increasing. Will it work? No, it should not, because we have a situation where this one is decreasing and that one is increasing, so that means the ratio becomes smaller and smaller. It can't be greater than 2/3. Then we get here and we move around here. Okay, this one, they are both increasing, so not really fancy for our work. We get to that smaller one, the cosine is decreasing, the sine is increasing, so I would want to believe that we are winning over there. We should. And then we get here, this one is decreasing while the sine is increasing, so this looks like it should work. Here they are both decreasing, this one should not work. Okay, so from what we have here, we've only got two areas where this is the case. Of course, this one at this point Q, they are equal to exactly 2/3. So there is the story. But now if that is 2/3, the tangent function would be less here. So this means we can't consider this. We cannot consider this. Okay, guys, this is just not logically making sense now. It looks like I have to overlay the tan function now to make sense of it all. Okay? It's not a big deal. If we overlay the tan function, we know that this becomes an asymptote, isn't it? I'm going to overlay the tan function. I want to see if what I'm thinking is correct. I'm going to overlay, then we're going to use the red one to draw. So we know that tan of 0 is 0, right? And then it approaches the asymptote. It's going to pass there. And then this one approaches the asymptote. It's going to be like that, right? It's the tan function. Second thing, tan in the third quadrant is positive, so it's going to start here and approach the asymptote. And in the second quadrant, it's negative. It's going to approach the asymptote. Sorry, the x-intercept. So this is how the graph is going to look. Now let's think about it. When is this graph above? Remember at P, this is where it is equal to 2/3. So this graph is suggesting that technically it should be here. This is good, although we said no. So it means our analysis was not quite excellent. So that is good. And also we can see that, okay, we mastered this one. We mastered that one. But here it becomes less. So I'm trying to figure out, because these graphs were like, okay. So I think the logical explanation here, if you just want to look at the graphs only, would be to say when they separate, approaching that point, they separate, one decreasing, one increasing, but approaching this point, the ratio is smaller. I would suggest that. And then when they separate away from the point where they are equal, such that the numerator increases and the denominator decreases immediately after that, then we can safely say the ratio will also be greater. So this is exactly what's happening. Can you see here? They're separating from exactly the point of being equal. And we know that, but again, the separation is strange this time. This one is decreasing while that one is increasing. Hey, yeah, bafowethu. It is what it is. What can you say? What can you say? Anyway, what we can use is the gradients, that this one is changing in a big way. It's becoming very small. Whereas this one is changing less, maybe. I don't know. But anyway, when we overlay the graphs, we get a clearer impression. I think the best way is to overlay the function, as you can see that, yeah. But all I can say is that if these two graphs are going in separate directions away from the point of intersection, it simply means the ratio is going to be bigger than when they were equal. But when they are both increasing in the same direction, the ratio should be less, as you can see. And then, of course, it continues to be less up until they are then equal. Of course, it still increases slightly, but it's less than when they are equal. Then it becomes there. And then when they separate immediately after the point of being equal, the ratio increases greater than that. I guess this is the sense. And then once we hit some serious issues there where we cannot define, then as they decrease together towards some point of intersection, we say the ratio is less, I guess. Anyway, guys, that's the little bit I can say. I think to overlay the 10 graph here was a better plan, so we can easily see that, well, x must be less than minus 90, but greater than minus 180. Right? No. Wrong. Remember, this is where they are equal. After that, this is less than, and we want it to be greater than. So this means our x must be less than 90, minus 90. But greater than minus that value, 146,31 degrees. Okay, that's the first one. Or x must be less than 90, but greater than 33,39 degrees. Of course, to overlay the 10 function, I think was the best plan. But to read it from here, I tried to find the signs to it, but yeah, maybe we can easily say from the point where they are equal, when they separate, then the ratio must be greater, I guess, because this is how it's going to go. And then we see the same again when they separate from that point up until we get to the asymptote. It should be like that. When they are moving in the same direction up until a point of equality, then we can see the ratio is less than the 2/3 that defined it. So that's another way one can look at it. Remember, sometimes you study things as you solve. You will never know beforehand, but you've got a lot of things. Overlay the graphs and you will win. You've got a rough work page to work with. Right, we get 4 marks, so this is 2 marks, guys. It's good. It's not so easy. This one is not so easy. But we always try and find some sense in it. Yeah. So we've got 8.4 says, what will the equation of g be after the y-axis has been shifted 45 degrees to the left? Well, we know that g of x plus 45 degrees is going to be equal to 2 cos of x plus 45 degrees. It's as simple as that. I don't see anything else, so I would leave it here. Okay, guys, you can see that over familiarity with these functions is mandatory. Less familiarity results in disaster. So open your eyes, guys. This is why I tell you, study these back. When you have answered the questions, go and study. Like, how would you answer this question using the graph only? You can see that to find some sense in this, we had to revert back to overlaying the graph as we understand it, then trying to use the knowledge that we have, then to figure out where does it work. And you can see that there is some sense in what we eventually said. When they separate or going in different directions in terms of gradients from the point of being equal, then the ratio is going to be bigger than the ratio that defines the point where they are equal. And again, when they approach another point, it's going to be less than the value that we need. Again, when they separate immediately after, it seems to make sense because there's a consistency in that logical thought process. Okay, let's do question 9 quickly. Right, question 9 says a vertical pole AB is shown in the diagram below. AC and AD are still cables anchoring the pole to the ground at C and D. B, C, and D are in the same horizontal plane, so this is suggesting that we are in the same horizontal plane there. The length of AD is 46 meters, this is given. The angle of elevation of A from C is 12 degrees, there it is. ACD is 56, yeah. And ADC is 50 degrees, yeah. So we are good. So let's get to business. Again, folks, I've shown you how to deal with this. You know, this question used to be asked in a very strange and higher grade manner. Lately, it's certainly standard grade in the manner that it's being asked, and I wonder why. Write down the size of CAD. Okay. What would be the size of this angle? Of course, we know that this is going to be 180, so CAD is going to be 180 minus the sum of these two, 56 plus 50. So this is 74 degrees. Of course, this is from the sum of 3 angles of triangle ACD. At this point, we just needed to write the answer, but we need to provide some reason because where did it come from? You copied or what? Calculate the length of AC. That's easy. We want that length, so we can use the sine rule. In triangle ACD, we know that AC over the sine of the angle opposite it, this is going to be sine ADC, right? Is equal to, we can use the side AD divided by the sine of the angle opposite it, which is ACD. So this is because of the sine rule of triangles. So this implies that AC over sine ADC, this is sine 50 degrees, is equal to AD 46 divided by sine 56 degrees. So we then cross multiply this. We know that AC is, now we've got ourselves here 46 into sine 50 divided by sine 56. So this gives us a 42,50 meters. Is it meters? Yes. Great stuff. To 2 decimal places. Remember the general instruction told us so. So how many marks there? We get a mark for this. Substitution answer. Right. 9.3 says, we need to calculate the height of pole AB. So we're going to work in this triangle. So in triangle ABC, what seest thou there? We know that basically sine of ACB is going to be AB divided by AC. Right, so this is sine of 12 degrees is equal to AB there, the tower, divided by AC, which is 42.50. Cross multiply there. Therefore, AB is going to be 42.50 into sine 12. So this gives us 8.84 meters to 2 decimal places. Okay, guys, we'll be told time up. As you can see, guys, this thing, you need to really work hard. Of course, it's easy when you're not explaining this to anybody and trying out other ways in the process. You can actually save some time. But you can already see precision is key here in what you do, because you can see you can easily not finish. Okay, as you can see, I did not easily cruise. Anyway, so this is what it is, guys. You need to be quick. For me, I would say finish this in 1 hour 30 minutes. Yeah, finish it. And then spend the 30 minutes checking some things. How many marks was this? 2. So substitution answer. Okay, cool. Right, so let's look at 9.4. 9.4 says calculate the area of triangle ACD. Okay. Area of triangle ACD is going to be half AC times AD times the sine of CAD. That's the area rule. So this is going to be a half of AC, 42.50, AD, that's 46, sine of the angle, what did we get? 70 what? 4. So of course we'll be told, hey, 0.5 ngazosiphela apha ndibhala into engapheli ngelo xesha nisibhalela inyongo ngoba ke niyakwazi uhlala nibhale nje amafutha nje nina ndiyanazi nisibhalela inyama yebhokhwe. This is 9.63 meters squared, remember. Correct units, guys, will be punished if you don't present them correctly. So for setting this up, substitutions and answer in the correct manner. And of course, folks, we take it down to the Y, isn't it? So we enjoy our 9 marks for a total of 100 marks. Sigqibile, re qetile ons klaar. Sikopetsa. Siqedile, siqedile. Akethi kuyalijeta. All right, guys, that was a nice paper. I hope you enjoyed it. Give it a thumbs up. And you may consider subscribing if you have not, because there's plenty in this channel that is still to come, and there's plenty also for you to explore. So good luck. I'll see you next time. Bye-bye.